then. The third problem, so it is a subscription service. Yeah, I don't really have a good link that I can provide because they're not public. I'm just looking off of images I have saved on my computer. So I'm just like describing it again, like out loud. Hopefully that's enough. Yeah, so the third problem was about subscriptions, and the idea is that there are a bunch of days. So Bessie is watching TV, and there's a bunch of days where she wants to have the subscription. So the days D1, D2, D3, and so on. So on these days, up to DN. So on each of these days, Bessie wants to watch TV. And what she can do is she can purchase a subscription for a contiguous amount of time. And if she purchases let's say she purchases a subscription for T days in a row, then it will cost her T plus K. That is the cost of a subscription of length T contiguous days. And she can buy as many subscriptions as she wants. She can like end her previous one and then start a new one like a couple of days later. She can basically do this however she wants, but it basically just costs K, a flat fee of K for each time she starts a new subscription, plus the amount of time within like the subscription interval. And so the question is, what is the minimum amount of basically what's the minimum cost she needs to be able to watch TV on all of her desired days? And for bounds, n is less than or equal to 10 to the 5. And the d's are up to like, the di are up to like 10 to the 14. So kind of similar to the first problem, we cannot iterate over every single day individually in the full solution. We'll instead only be able to iterate over like the di's. So let's look at this problem from a greedy perspective. So the first day is D1. There's no advantage to starting a subscription earlier than D1, right? Because you don't need to watch TV before D1. And you're starting a subscription earlier only costs more because each extra day you add to your subscription is at least a +1 in cost. We might as well start our first subscription on day D1. Now let's fast forward to D2. The question is, should we include D2 in the same subscription? So should we extend our old subscription all the way up to D2? Or should we just like end on D1 and start a new one at D2? Basically, those are the two options we have. Because if we are to extend our old subscription to D2, then we just take that, we go all the way up to here, right? And this will cost D2 minus D1 +1 and then plus K. Or our other option is we end our old subscription. If we're going to end it, we might as well end right after D1, and then we start a new subscription starting from D2. And the alternative cost of that would be it would be 1 plus 1, so 2, plus 2K. As you can see here, what we're really comparing is because this 1, we can think of it as originally here, this initially already costed to start a subscription there originally at D1, this already costed 1 for the number of days plus K. And so the extra cost that is incurred when we consider day 2 now is either to be added to our old subscription, so that adds a cost of D2 minus D1, or starting a new subscription, which adds a cost of K plus 1. And so now when we look at these two, value quantities, this is like how much we add to our total cost, depending on which choice we make. Then we just make a greedy choice. If D2 minus D1 is less than K plus 1, then it is greedily optimal to keep the same subscription, like extend the subscription. Otherwise, it'd be start a new subscription. So essentially, we're just adding the minimum of D2 minus D1 and K plus 1 to our answer. And actually, after that, we get a D3, we apply the same logic, right? We either extend our subscription onwards to D3, which costs D3 minus D2, or we start a new subscription, which costs K plus 1. And so our greedy just ends up being quite simple. At the end of the day, we're just doing a for loop over all di. We're taking the sum of from I from 1, or I'll say from 2 to n of minimum of di minus di minus 1 or k plus 1. And then plus an additional k plus 1 for the first one. That would be our answer. So this works in O of n. Any questions on this problem? All right, then, yeah, so in that case, oh, wait, hold up, yeah. Yeah, so in terms of code, it actually ends up being quite concise, right? Because computing this is essentially a for loop. I'll be literally rewriting like a for loop. After I take in the input, I'll be doing like a for loop from, I guess in code, it would be, we would usually zero index it. So it'll be from like I from 1 to n. We add to our answer minimum of, what was it, di minus di minus 1 and k plus 1. Initially, we have answer is equal to k plus 1. All right, any other questions? All right, then let's turn it back. Let's turn it back to these slides.
Yeah, thank you. I think there are a couple questions. Let me see.
Yeah.
Max, do you see that chat?
Yeah, I
chat
see it now.
yeah.
Yeah. I guess I'm assuming when you say I'm assuming you're referring to the Python function when you say map like with parens, because that's the only context I know for that function. I guess I mean I think you can like technically do everything in Python with just loops. I think it's just a matter of how much fancy Python syntax you choose to use. Yeah. I mean generally I use C++, so I'm not too familiar with the intricacies of Python, how to write the most efficient or shortest code. Yeah.
Thank you, Max. Students, any other questions? Okay, let me have a last slide to share with you. Yeah, if some of you passed this USACO bronze this time, congratulations. If not, we prepare some classes for you. The first one, we have the March public USACO mock test. It's on March 18th from 4 to 8 p.m. Eastern time. So, we have all these levels. You can have extra practice before the last US Open contest this year. Also, we have summer on-site camp. It's the end of July, 2 weeks. So this can boost your performance. It is in San Jose. We have limited seats, 20 students for each level. Finally, we have weekly weekend class. Our spring quarter starts on April 1st. Our summer quarter starts on June 24th. These are all 10-week online class. You have 2-hour instructions every week. Also, you have office hours and homework. Hopefully, these kind of resources can help you keep improving learning in coding. I think that's all for this session. Also, we have this recorded on YouTube. also this kind of a broadcast in YouTube too. You can find the video there. If you have any questions, you can review this session later. Again, thank you, Max. Thank you for helping us explain these problems. Yeah. Wish you all have a good night.